Okay. So let's go into that. The 10 should be good. Well, hopefully 11 will be.
Yeah. All right, so we beginning the quiz then?
Yes. So 90% confidence level. First, we have to get that from the probability applet. I really just have to write the main one down.
Okay, see, I can read this, and I remember reading it, but I have to go back. All right. Margin of error.
I lost my actual quiz. What is this? My fun.
Okay, so the formula for margin of error is z times sigma divided by the square root of the number.
Yeah. So the for the 90% confidence level is 1.45.
Wait a minute. Where is my... Did you put that into the applet, or what did you do?
Yeah. So I just did top of the probability applet.
And that's the center. So 0.126.
No. Z-score is 1.645.
Yeah.
I don't know. Okay.
So you type in the area there, right? 0.90.
Right.
And shade only the middle.
Right. Oh, why did that change? I did that, but it changed on me. Ah, gotcha. 0.1645. Okay.
So I'm still echoing. Volume down, which normally does it, and I'm still echoing. Why?
Yeah, you are echoey.
Yeah. It's really bad.
Michael, you're echoing too.
So, which of the following statements is true? The first one is true, isn't it?
Hold on, I'm not even there. Wait, so we want me to calculate the margin of error.
Oh, right.
I'm going to try putting headphones on the echo.
Hey, I gotta go get my calculator. Hang on, guys.
Okay.
Okay, let's try this. Don't like that it echoes. Okay. Am I echoing now?
Yeah.
More. Okay. Let's do it. 2.
Okay. All right. So 1.645 times 50. I got 16.45.
Okay, just give me 1 second. I'm just trying to see if I can echo.
Okay.
Okay, is that better? Okay, is that better? Nope.
Yeah. Well,
For you, it's still echoing for me.
what'd you get, Michael?
Got 16.45.
Okay, that's what I got too.
I'm not sure how to fix it. So and echo. Oops. 5. What did you guys get for 3 again?
16.45.
Awesome. Which following statement is true?
The third one, I think. At least that's what I have in my notes. X bar equals the sample mean, or the point estimator.
I think you're right.
Lower limit. Okay. 25. $1.96. It wants the lower level. So we're doing values. Minus z-score, which is 1.96. Times the let's see, standard deviation divided by 4. 198 and 5. What did you guys get? Calculated it.
Still figuring it.
Okay.
Me too. What'd you get for the lower?
198.315.
Yep.
Okay, what formula are you guys using? Because I'm a little lost here then, because I was using a different formula.
So it's the value, so the x bar minus the z-score times the standard deviation
Sigma.
divided by
Okay, so what'd you get for the z-score then?
1.96.
Okay, so I'm doing that, and I'm subtracting the 1.96. I'm getting 7,402.065.
Whoa.
I think maybe you're missing parentheses.
Let's see, parentheses, 526 minus 1.96, parentheses.
We want to do parentheses after the minus. We do minus parentheses 1.96 times parentheses.
Why would I do that?
Because otherwise it subtracts or before multiplying, because it does it in order rather than the order of operations.
Okay. Times 113.
Yeah, those order of operations are kind of tricky.
You don't get ya.
It's not really so much the order of operation, how to figure it out on calculator.
True.
Okay, so 498.315?
Yes.
Yeah.
That's the upper end, correct? No,
Yeah.
that's the...
Sorry, lower. It's lower.
That's the lower, yeah.
And it wants the upper. So we just add instead of subtracting. I was trying to do, but then I subtracted again. Which I was doing this morning.
Okay, 553.685. Is that what you got?
Yes.
Now, when we enter this in, are we just doing the number, comma, the next number? Because you don't want to enter it in wrong.
No, because it says what is the lower limit and then what is
the
the
lower
upper
limit.
limit.
Never mind. Sorry. I jumped ahead.
Your question.
Gotcha. Okay. So what would happen to the width of the confidence interval if Gina increased the sample size? That...
It would decrease, right? Because as you increase the sample size, the confidence level. Well,
actually, hang on.
yeah, it makes it more accurate, I think.
I have notes on that one. Or I thought I did anyway.
I think it's decreased as well.
Okay. Okay. All right, so what would happen to the width of confidence interval if Gina changed it to a 99% confidence? It would increase.
Decrease because the
width would increase if the confidence interval increases.
But it makes it more accurate.
No, because in order to be 99% sure, you're going to have a bigger area, a bigger interval. At least that's what they said on the video. I just watched that before the
You're right.
meeting.
4.2.
Yeah.
10. So it increased. Makes sense.
Yeah. Okay, so Bright Bulb Light Bulb Company is planning to study to assess the average life expectancy of their light bulbs. They know the standard deviation is 400 hours. Want 95% confidence interval with a margin error of 50. Okay, so what sample size do they need?
So this is the n equals z times standard deviation divided by m formula.
Okay, find that one. Right, okay. So, are they asking for 95%?
Yeah, so it's 1.96.
Okay. So, we have 6 times 400. So I have to put all of that in parentheses and then do the square. Then do the.
Yeah.
Okay. Do it again.
What'd you get?
Hold on. I was making sure I did the parentheses. About 240. Because you need to round up.
Yeah, 246.
Yeah, 245.86, so 246.
Yeah. Good.
Okay. Alrighty. Yay, I did it right. Okay.
Job.
All right, the mean. When we're computing this one, are we using the? Never mind. I got it. Never mind.
Okay. Either of you have it yet?
Not yet. Hang on. Okay, so the lower limit I got on this one. Did you get it, Michael, yet?
Mm-hmm.
I got $88,001.
I got 99,002.
What'd you get,
I
Michael?
got 99,008.
An 8?
Yep.
Okay, so we're doing the x bar minus the z times the sigma divided by the square root of n, right?
Mm-hmm.
Yeah.
We're using 111,000
Yeah.
for the x bar.
Yep.
Okay, the sigma is 36,730, and the number is 36. All right, let me try that again.
And the z-score is 1.96.
Okay. minus times okay, that time I got 99,001 or 2 if you round up.
Okay. Okay. That's what I got.
That's what I got.
Okay, I got it too.
Okay, I got you.
I don't know how I
I
got
don't know
that
how I got
7,
that.
but
It's kind of always easy to get a number off. Okay.
Okay.
So I have the
So
upper
I
limit
have upper limit
as well whenever you guys are ready.
ready.
I do too.
Okay. So did you
Okay. What did you get?
I got 122,998.
Okay.
Okay.
Me too.
Me too.
And because
And because
the whole
the whole
matter of it,
matter of it,
we could round up
we
if
round up if
we're right.
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 Sometimes that's
Sometimes that's good.
Is that what you got, Michael? Was 122,998? Are you still working on it?
yeah, that's what I got.
That's what I got.
Okay. So number 12 should be all of the above.
Yep.
Yep.
Cool.
Cool.
Because if the sigma is unknown, then we're going over to the t, whatever lesson 11 was covering, the t
Yep.
interval.
Yep.
The t, yeah.
Right.
Right.
Okay. Yay, 100%.
Oh yeah.
Oh yeah.
Oh yeah.
Oh yeah.
Okay.
Okay.
My computer.
My computer.
Okay.
Okay.
Let's start.
Let's start.
Yeah.
So have either of
So if
you
either of you
heard from Patrick?
heard from Patrick?
No.
Oh.
Okay.
Okay.
I have not. I don't know if he is just not able to figure it out or what the deal is.
Yeah, I'm not sure either.
I'm not sure either.
Okay, so
Okay,
number
so
three
number
in the group quiz.
I got we assume sigma is unknown.
Yeah.
Yeah.
Me too.
Me too.
All right.
We repetitive here.
Here.
Okay.
I don't know it.
Know it.
Okay, so number 4 is sigma known. Well, it just said it's unknown, right?
Right.
Or we-
Right. Yeah.
Okay. So what is the value of t for number 5 then? So that formula is x bar minus the mu divided by the z divided by the square root of n.
It's S, but yeah.
Yeah. Is that what I said? I said z. It's S. It's
You said
S.
Z.
Oh, sorry. I was
You're
looking
fine.
at S. Okay, so x bar is 11 minus
8. Okay.
divided by I got 7.
I got 1.5.
1.5.
Okay, see, I'm doing these parentheses wrong. Hold on. I don't know
Put
what
the
my
upper
problem.
denominator in a parentheses and the bottom denominator in the parentheses. That might help.
Yeah.
Paste. We're using SPSS in this one. Let's see.
1.5? Is that what you guys got?
Mm-hmm.
Okay.
Okay, I'm going back into SPSS because it logged me out.
Okay.
Copy them.
Yeah, I'm going to copy and paste and see if that works. It should be the same values that we used in the individual preparation, but see, it doesn't want to load. Oh, there we go.
So the test value is 40, right?
I'm having trouble getting into it, so just
Okay.
give me another minute.
Okay.
It's like refusing to log in.
Are we going under Analyze?
Yep.
Because he taught us something different. He went over it so fast in that video that I could not keep up. It's under Explore.
I don't think so.
It's under the one under
Explore.
It's
there.
compare means and then one sample t-test. Right?
Oh, that's what it was. Yeah. Man, he went over that fast. Okay. What are we doing? The 95% confidence interval? Hang on. Oh, okay.
Oh, whoops, I didn't mean to do that. What's the value that needs?
0.05?
Isn't it 40 that you test? Your test value? Is that what you're talking about?
Yeah. Hold on. Nice.
You want to test their claim? You select the...
Wait, so it's 98.6 that we're testing. You enter the null hypothesis.
I have no idea.
Number 6.
Yeah.
And so
Oh,
you enter,
I'm sorry. I'm sorry. I'm
completely
doing the
lost.
wrong one.
okay, so when
Sorry.
you hit, let's see. So you go to Analyze, Compare Means, and then one sample t-test, and then variables over, and the box says test value, and that is put null hypothesis, which in this case is 98.6.
Right.
And click OK.
Okay. So what? So they're asking, what is X bar?
So the value. 8.6. I think so. Just using tricky wording again.
That's just the sample mean, right?
That's what I was thinking. It should just be. It's just a null hypothesis. 98.6, isn't it?
Well, if you do the one sample statistic,
It's asking us for that in a different question. Let me see here.
because I'm showing a mean of 98.22.
It's the. Hold on. That's the sample statistic. It's not asking us for the sample statistic. I don't think. I'm checking.
Oh.
I'm not entirely sure. That's why we're looking it up. Oh no, you're right. It gives us 98, whatever it was.
98.220.
Yeah. Michael, do you agree with that?
Yeah.
Okay, and then
Yeah.
S was
Is the sample standard deviation.
right, so it's 0.922.
Yeah.
And then the T-star is...
What would it be? I'm sorry.
The standard deviation is 0.922.
Okay. I want to make sure I see it. Okay. And then T.
Negative 1.843.
Negative 1.843.
Yes.
Yeah.
And the p-value is that's where it's the two-tailed test. So it's and this is saying it's different than, so it is a two-tailed. Nope, it's less than. So we need to figure out the area. So when it's a two-tailed test, it's different than. Then we can use the two-tailed number that it gives us, but it's asking for a sense. So we need to figure out the value that's left.
So it's going to be half of that is what it is.
Sometimes. So I'm not sure. I didn't say exactly. Well,
On the video, he basically said if you're doing a one-tailed test, you just take the two-tailed and split and divide it by 2.
so if I put the area in as 0.81 and just highlight side, highlighted both and then took off the right side. So it's 0.405, or if it's is it asking for
0.0405. Right? 0.0405?
Hold on. I got 0.405. Is that what you said?
0.04.
There's no zero
Well.
in between the 4 and the point.
None.
405.
Yes.
0.405.
That's what I.
Okay.
Well, okay, are you dividing that 0.81 in half?
It's 1.843. Sorry, wrong one. I'm looking at the wrong number. No, you have to. the area into the applet, I think.
So the 0.081.
Right. And then you just left side. Oh, I got 0.4677 this time.
0.08.
I'm not really sure. I'm not really sure what you're doing. I just know that when I watched the video, he said you take the 2 tail and divide it by 2 if you're only doing a 1 tail.
Didn't say put it in the applet. No, I think it's 0.045, 0.41, whatever.
Tell me again how you did that. You went into the applet and you put in what?
Yeah, but it's not right. You're right, but it's just divided into 2. It confused me with like the area and all of that.
Yeah.
0.041. Yes.
0.041. Yeah. 0.041.
Okay, so then are we saying that so the level of significance is 0.05, so it's less than the significance, which means we're going to, oh man, why can't I ever remember which?
I know. I have it written down here. Give me just a second.
Okay, if the p-value is less than the significance level, we reject it.
Okay,
Have we
is less
failed?
than the level of... So it is less than. The p-value is less than.
Michael, are you good with this?
Yeah. Yes. The p-value shook me a little bit, but I got my notes, so I'm
Okay.
writing this stuff down.
Okay, so now this is the one you were on before, right?
Yes. Yes.
Okay. How do you get back to the place you paste the data in?
You click the little X side, and it'll take you.
X.
And are you
I don't see an X. Oh, you want me to
create a
X out
new
and then come back?
formula?
Gotcha.
I mean,
Gotcha.
sheet. Okay, so this one's, yeah. Good.
Okay, so what are we putting in here?
The first alternative hypothesis is just asking for the p-value.
40.
What?
Huh. Yeah, it's just looking for the p-value. So isn't that equal to the two-tailed
Test value?
thing?
So it's just 995.
Wait a minute. I'm confused here. We're doing the one sample t-test. What are we putting in for the test value?
40.
40 because
Okay,
that's
Okay. It's the
hypothesis.
only number they really gave us. Okay.
Yeah.
All right. So your first alternative has a what one? What's the p-value?
The two-tailed.
Right. So the p-value is 0.498.
In 11, it's not a decided test. It's a double. It's just saying it's not equal to.
Oh, because it's asking you. I see. It's not asking for less than or greater than. Right.
It's just saying it's not equal to.
Right.
So it's two-tailed.
Okay.
Then we fail to reject the null hypothesis because it's greater than this significance value. Yes.
Right.
Okay.
All right. You just.
So then in 13, the p-value decreases because it's
That's when you would
one
divide it in half.
Yes. P-value is less. So all we have to say is it decreases. And then you continue to fail to reject the null hypothesis because even half of 0.995 is greater than 0.01.
Right.
So
Sorry, number 13. You cut out there. Okay, so the p-value decreased.
yes.
Mm-hmm.
Okay, gotcha. All right. So compare the width of the confidence interval for question 11. Which one is wider? Well, if you increase again.
Okay. Let's see. Yeah, I'm not. I can't remember off the top of my head. So here, let's see. I mean, do we have to figure out the confidence level, or should we know this by having the data we have?
Seems like we should know this, but
I
Yeah.
was thinking. I don't know. Well, it'll give us the, okay, so we can figure it out by going to do it in SPSS. In section, let's see, here in section, get in the book. Point 1, scroll down, it'll say in step 3, summary statistics, and it tells you how to find it with SPSS. It'll give you the confidence interval. You scroll down. Oh, it's just in the normal statistics. Information. It's weird, I never noticed that. gradient. Are they even different? Because nothing's changing. It's the width isn't changing.
I guess I'm not really clear on what.
Does the confidence level even, or the confidence interval even change? That's what I.
Well, isn't there something that talks about if the p-value increases, then the level of, I don't know. I know I took notes on this, but now I can't seem to find it. You know?
Mm-hmm. Where's my...
Wouldn't 11 be wider?
What makes you...
Because your p-value is the probability value, and you have a probability of 0.995. And if you have, in question 13, you got your greater than sign there, so you cut it in half, right?
Mm-hmm.
So you cut 995 in half, which is whatever that is, but your confidence interval, your 11 would be wider than your 13 because it's
Not
cut.
just... Well,
Well, the question is, if the p-value is lower, does the confidence interval decrease?
And I don't think so, because the confidence interval equation is the value minus the z-score, or the t value, the whatever, times the standard deviation divided by the square root of n, and it doesn't have anything to do with the p-value, I don't think.
I'm just going to look here.
What's the z-score's relation to the p-value again? If I could get that straight, maybe I could remember the difference. The width of a confidence interval depends on the chosen confidence level and its corresponding value of z, as well as the sample size. I don't think it has any influence on it.
Yeah, because it's not talking about the margin of error.
Yeah, that makes sense.
It's just thrown in there to confuse us, and since we didn't find it in the book, we're not sure.
Okay.
Since we don't distinctly remember.
They're the same.
Okay.
I think so.
All right, let's go with that.
All right. Yep, 100%.
Okay. Well, that was confusing for no reason.
Yeah.
Yeah.
Well, good luck on the homework.
Yeah.
Yes, you too.
All right,
Okay, so-
everybody.
All
Have a
right.
good day.
You too. Bye.
Bye-bye.